The Ministry of Sovereign Intelligence, Agent 26, Sterling Vane. Real science, real stakes.
Vane, do you copy? The readout just jumped, all the bladders, simultaneously. She's about to the whole delta.
I copy. Cooper.
You copy? The hydraulic pressure wave will propagate through the entire channel network in minutes, fast enough to collapse every bank before anyone can respond. Every access route floods, and whatever Khalil buried in the sediment gets pulverized into.
I heard you the first time.
Then do something. Sloane is screaming at me from London, the dean's on the other line, and I have a very expensive piece of kit up here that is telling me we have 40 seconds.
I'm already doing something.
Are you blowing air into the ground?
Into the distribution trunk. There's a difference.
That's not possible. The pressure should have.
Pascal's principle applies when pressure is transmitted through a confined, nearly incompressible fluid, Dr. Khalil. You built your weapon out of water. I introduced a column of air into the trunk, feeding it. The physics was never entirely on your side. It was simply waiting for someone to ask it the right question. 16 hours earlier, London.
Come on. I updated my biometric profile literally this morning.
You updated it with your left thumb, Cooper. The scanner reads right. It's been that way for 3 years.
I was carrying a coffee.
You're always carrying a coffee. That's not an excuse, it's a pattern. Also, your level 4 clearance lapsed at midnight. You're effectively a civilian.
I'm Agent 14.
Agent 14, with expired credentials and a wrong thumb. Shall I have security escort you to the gift shop?
Good morning, Sloane.
Agent 26. You're 7 minutes early. That's alarming.
Lagos was straightforward. Egusi seeds. The market near the marina. The vendor insists they improve concentration. I made no promises on your behalf.
You brought me seeds.
They're very good seeds.
Can anyone?
Done. The Dean convened a briefing 20 minutes ago. Khalil's system went active overnight.
I know. I read it on the flight. Analog copy Cooper's printer, before he password protected it with his cat's name.
It's a strong password.
The cat is called Biscuit Cooper.
3 years ago, GCHQ flagged Dr. Fatima Khalil, formerly of the UN's Integrated Drought Management Program, as a person of significant interest. She had theories about hydraulic systems that made certain governments uncomfortable. She has stopped theorizing.
The Okavango Delta, Botswana. Roughly 15,000 square kilometers of interconnected waterways, floating islands, and one very annoyed map interface.
She spent 3 years embedding a distributed network of pneumatic bladders into the delta's substrate, connected by a single buried distribution trunk that branches outward to every hydraulic junction across the Pauna system. No dam, no visible infrastructure, just pressure, stored, waiting.
A dead man's switch wired into the water table itself, with a single manifold at its heart.
Precisely. If she's detained, if her uplink signal is severed by any means, the bladders release simultaneously via that trunk. Pascal's principle does the rest. Pressure applied to any point in a confined, nearly incompressible fluid transmits equally and extremely rapidly to every other point in the system. The pressure wave propagates through the full channel network in minutes, unstoppable, simultaneous, total. Every bank collapses, every access road floods. And the financial records she's buried in the sediment at 17 sites across the delta are destroyed beyond recovery.
Records tying half a dozen governments to illegal water privatization schemes. That's what she's been extorting with. 3 nations have already paid.
A fourth one of ours received the invoice this morning.
She's made her own. Capture the weapon. Arresting her completes her circuit.
Every conventional approach, signal jamming, physical restraint, cutting her uplink triggers the release. Our technical teams have verified this 4 times. which is why I'm talking to you, Vane, and not a battalion.
The distribution trunk. It's a single buried line feeding all the bladder junctions before it branches.
One main supply trunk. She had to engineer it that way. Simultaneous pressure release requires a single pressurized source. Branch it before the trunk, and the timing collapses.
Then the trunk is also the weakness.
You'll travel by commercial flight to Morn, cover as a wildlife survey consultant. From there, a solar-powered microlight to the Delta perimeter. Then, by traditional mokoro, into the interior. Cooper runs aerial comms and surveillance from the microlight throughout.
I've already preloaded the Delta's full hydrological dataset into my AR field suit. Current flow rates, bladder junction coordinates, real-time pressure mapping.
Bring a canoe paddle. The reliable kind, wood.
I was going to bring a carbon fiber.
Wood. 16 hours later, the Okavango Delta. Interior. Approach.
I've got your position on the overlay. Khalil's platform is 400 meters northeast along the main channel. I'll hold altitude and orbit keep comms open. The pressure readings on the trunk line are elevated. She knows something's moving in the Delta.
Then, let's not keep her waiting.
Vane, 200 meters. Her uplink frequency has gone to burst mode. She's armed it.
She's nervous. That's different from ready.
That's far enough. I know who you are, Agent 26. I know what you were sent to do. And I want you to understand very clearly that the moment your ministry moves on me, the moment anyone cuts my signal, 14 years of evidence goes with the water.
I understand completely.
Then stop moving.
You've built something genuinely elegant, Dr. Khalil. A Pascal system pressure fed through a single trunk into a branching bladder network. Pressure at any one point transmitted extremely rapidly to every other. The water itself is your defense. I have to admire the engineering.
Don't patronize me.
I'm not. You've exploited a fundamental principle of fluid mechanics to make yourself untouchable. It's remarkable. It has one flaw.
It's Vane. The bladder pressure monitors are spiking. Her hand is on the switch. What are you doing?
Pressure reading at the distribution trunk junction. Current figure.
Trunk line pressure, 3.4 bars absolute. Junction volume, approximately 40 liters. Estimated minimum gas volume to break hydraulic continuity at atmospheric 0.8 liters.
Hum.
What flaw? There is no flaw.
Pascal's principle demands a confined fluid with very high resistance to compression. Water resists compression extraordinarily well. It transmits force with very high efficiency in every direction. Gas does not. It compresses significantly before passing force onward. Introduce a gas pocket into a hydraulic line, and the transmission becomes strongly damped. Energy goes into compressing the gas rather than propagating the wave cleanly downstream.
What are you? That's a canteen valve.
The distribution trunk runs directly beneath this marker, the single line that feeds every bladder junction across the Delta before the network branches. I tapped it when I stepped off the mokoro. There is now a column of air sitting inside your hydraulic manifold, between the pressure source and every branch it feeds.
Vane, the bladder pressure is dropping. Not spiking, dropping all across the network. How is that the trunk readings are?
Your dead man's switch is spent. When your bladders release, and you should release them, there's no leverage left in waiting. The pressure wave will travel back through the trunk until it meets the air pocket. And there it will be absorbed. The gas compresses, rather than transmitting the impulse, is stored as compression energy, dispersed and weakened before it can propagate downstream. The shockwave your system was designed to deliver sharp, synchronized, simultaneous arrives at every branch as nothing more than a weakened, desynchronized pressure change, not a weapon. A whisper.
The volume, it can't be sufficient to...
The trunk is a closed system. The gas doesn't need to fill the network. Plus, It only needs to sit upstream of every branch, one compressible interruption at the source, and Pascal's transmission loses coherence before the pulse reaches a single junction. You know this. You're a hydrologist.
The water isn't moving.
No, the water was never really on your side, Dr. Khalil. You borrowed it. I simply gave it somewhere better to be.
Full recovery of the sediment caches, 17 sites, 4 governments worth of evidence, completely intact. The hydrological survey team says the delta is entirely undamaged. I want it noted that my real-time pressure monitoring from the microlight was instrumental.
It was noted, and then filed under atmospheric conditions for your dignity.
Ooh, that's not what I...
How much air was it actually?
800 milliliters at atmospheric pressure. It compressed to roughly 235 milliliters at 3.4 bars. Absolute line pressure, but the volume was never the point. It needed to be upstream of every branch. Position, not quantity, was the variable that mattered.
She spent 3 years engineering a hydraulic weapon across 15,000 square kilometers of African Delta, and you neutralized it with less air than a bottle of Burgundy in the right place.
A good Burgundy. I'm particular about the analogy.
Well done. 26. The Botswanan authorities have Khalil. The ministry's position with the implicated governments remains diplomatically ambiguous, which is precisely where we prefer it. Enjoy your evening. You have until 7 a.
And then?
Something's happening in Reykjavik. Something thermal. I suspect you'll find it interesting.
Reykjavik. In March. Do we have cold weather gear?
You have cold weather gear, Cooper. Agent 26 will manage with a scarf and absolute certainty that the universe will cooperate.
The universe always cooperates. It simply charges interest. Pascal's principle states that pressure applied to any point in a confined fluid transmits equally and extremely rapidly to every other point in that fluid. This is why hydraulic systems work. A small force applied to a small piston produces a large force at a large piston, because the pressure fans out through the liquid with very high efficiency. Water is effectively incompressible. Under ordinary conditions, it resists compression so strongly that pressure travels through it almost unchanged. Push it here, and it pushes everywhere. But introduce a compressible element, a gas, an air pocket, and the behavior changes fundamentally at that boundary. Gas transmits pressure poorly compared to liquids because it compresses significantly before passing force onward. Introduce a gas pocket into a hydraulic line, and the transmission becomes strongly damped. Energy goes into compressing the gas, rather than propagating the wave. What emerges downstream is not the sharp, coherent pulse that went in. It is weakened, delayed, and desynchronized. The crucial detail is position, not volume. A gas pocket downstream of the branch point would only interrupt one path. A gas pocket upstream, in the single trunk line before it branches to every terminus, means every branch downstream receives only a weakened, desynchronized pressure change, rather than the destructive pulse she designed. Not a flood, a ripple. Dr. Khalil's system required 2 things, a nearly incompressible fluid and a continuous, unbroken column of it, from source to every terminus. I removed the second condition with less air than a bottle of wine in exactly the right place. The delta's channels still run. The birds came back before I reached the mokoro. Physics, when properly consulted, is a remarkably cooperative colleague. It simply asks that you listen to all of it.